Good morning, ladies and gentlemen, here in Silicon Valley at the Santa Clara Convention Center. Good morning, good afternoon, good evening. If you're joining us over the World Wide Web via Syscon TV's 2 million pages. In every top corner there is going to be our next keynote speaker. We're at day 3 of Cloud Expo, 9th Cloud Expo. Another day, another long day, lots of sessions, lots of discussions. I hope lots of conclusions, recommendations. To help us kickstart this, a keynote that I'm looking forward to very much because I like its title. You know, we always have this enterprise bias at Cloud Expo. We're pleased to be dealing with enterprise-level cloud computing in a way that no one else is. The DNA of enterprise cloud computing, if you can take that away from this room, it will be a very valuable asset. So let's say good morning to Willy Tejada from Akamai Technologies, and let's hear the answer to this question, Willy.
Thank you very much. Say good morning. So I listened to the Superstar panel actually this morning, and one of the things that was a constant theme that was going back and forth was essentially has the cloud arrived, and a lot of commentary on the leaders on that particular panel on how do they know it's arrived. For me, I have 3 young daughters, not always this young anymore, but I think my judgment in relation to whether the cloud has arrived is oftentimes based upon what they say and whether they've adopted in their vocabulary and the way that they actually work. So one of my daughters, she's going to school and studying environmental sciences, and she's buying books for this fall semester. And she says, oh, Dad, you know what? If I buy this other thing next to my book, I can get a series of quiz and tests and tutorials and everything else. And it's about 50% more than just buying essentially the physical book itself. And I ask her, well, what is it exactly? Is it DVD? And she goes, no. It's in the cloud. Is her comment. As if she's expecting me to just know what that is. And then the next thing is that my 15-year-old daughter, we're traveling actually down to visit her grandparents in San Diego, and I know she has homework for the weekend, and as we're getting onto the plane, she has her backpack, and she asked me if I have my laptop, and I said, yeah. And I said, do you have yours? And she says, no, I don't have mine. As long as you have yours, I'm okay. And I said, well, what about your homework? And she says, Dad, it's all in the cloud. And they use Google Docs and everything else that goes with that. And then she asked me, how come you have to bring your laptop? And I said, well, some of the stuff I have to work with is still on my laptop, so I have to bring it with me. And her common response is basically, that's lame. So, you know, in general, one of the things I'm just actually wanted to get to is that it's very mainstream. You know, it's in the way our kids work and everything else that goes with that. You know, I'm going to focus on one particular area of the cloud that is a little bit different than a lot of the other panel discussions and things that have to do with virtualization and cloud stacks. We're going to focus a little bit basically on the network aspects of things as it relates essentially to the cloud. I use this comment basically the cloud DNA or the DNA itself. And you know, when you think about DNA, the basic building blocks of life, you know, you have all of the building blocks there. It's everything that you need. The key element is that you have them in the right order. Or in one case, basically, if you're missing something, you know, what you can produce is something very dramatic and drastic. So when you take a look at what you're doing in terms of the building blocks as it relates to the cloud, in many cases, it's the same thing, where you're moving essentially compute, storage workloads, you're creating the virtualization stack, you're creating agility, as it would say. But again, if you don't get the right order, you get very much the wrong type of cloud. And really, you know, when you really think about it, just a little bit of levity from that standpoint. But I think what I'm trying to actually get to is that much of the first few years have been focused on building these virtualized cloud stacks. And it's all in the spirit, basically, of being able to dynamically move these workloads, whether it be storage and compute, within their enterprise, oftentimes basically within the private environment as well as the public environment. And one of the key linkages, aspects of that basically is going to be the network fabric that actually connects those pieces together. And you know, the cloud in many cases, for many of the businesses and industries, have really gone from complementary to the core. We've seen this very much basically in just things like commerce, where in 2008, when we saw a lot of physical locations in terms of the commerce facilities shutting down, Akamai, looking at network traffic and volume, actually saw in the commerce segment actually much of the traffic actually go up. And then again, whether you're talking about the public or private cloud, I work with a financial services institution, who told me just within the last 30 days that when a particular application is now down, it has greater impact to him for every minute that's down than if every physical branch location for that financial institution in the North America was down. So it's kind of gone from this complementary convenience aspect basically to the core. And again, the focus that I want to spend in this morning's session will have to do with the network components that are related to that. And I'm really going to focus on 3 areas, or just touch upon 3 areas of that DNA fabric that much of you are deciding to implement essentially in your enterprise, roll out, and what the strategies might be. One is going to be hybrid networks. The other side is going to be global access and mobile. And the other side of it will just be security from that standpoint. If you take a look at the network aspects of things, it used to be so simple. You could get just a private network, connect up your branch locations, VPN in. Everything was highly secure. Everything basically rolled up to typically a large data center, maybe a failover data center. But you bought your quality of service, your performance, your SLAs from one or a handful of vendors, and it was very easy basically to sort out. If you take a look at a lot of the talk in relation to what's happening, a lot of folks are talking about this hybrid environment. And hybrid in terms of compute and the compute data center stack is, can I move the things basically within my private data center and have it virtualized and very easily basically move the compute and storage workloads within my own enterprise. But more and more, they're making choices because of agility or cost per compute or cost per storage to move those workloads actually out of the enterprise into an Amazon, into a Rackspace, into a Terramark, into an OpSource, into any one of these, into a GoGrid, into any one of these types of environments that, quite honestly, might be on the public network. So this is consistent. This data and stat is consistent with what we hear from our own customers, and it's probably a bit biased because most of the customers that Akamai works with are on public internet. But rather than seeing flow happen between one environment and the other, up maybe 5 years ago, we used to hear, well, what's going to happen, basically the applications that are actually in the private data centers, they'll move to the public internet. What will happen in the public internet is that, the majority of those applications that are in the public internet that are mission critical might need quality of service and move to the private environment. And I think right now what we're hearing consistently across all of our enterprise customers is that it will be a hybrid environment, a mixture of their public and private network environments, and both will grow. And what they want is the agility to move the workloads between one and the other. Now, that simple environment now is no longer so simple. Now, when you're deciding where your compute and storage workloads go and your application transactions go, you first have to decide in many cases, one, is it going to go in, are you going to use software as a service and essentially rent infrastructure from one of the providers that's actually out there, Salesforce.com. I'm going to talk about a dynamic that's being pushed heavily with even Microsoft as they push Office 365 actually into the cloud. Do you choose to actually put the workloads there yourself, where you own the application but you're using the infrastructure of somebody else, like an OpSource or a GoGrid or an Amazon or a Terramark? Or are you simply basically utilizing one of the stacks that are available from many of the vendors here and building the private network yourself, but giving yourself the ability to actually move those virtual workloads wherever you want? Now you couple it with the network component. It used to be just one, either was dominated in terms of private. And now you have the public network environment. And because much of these applications can reside either in your private data center or in the public data center, you have now these two networks to actually converge. And how do you actually provide essentially a quality of service that spans both? And then you have the user access. And the user access no longer is actually just the branch, but it's actually the internet access user. It's business partners, it's customers. And then last of all, you have the device component, which is you have a number of these devices now that are accessing these pieces of infrastructure. So you have this world essentially that is no longer quite simple. Where can I put the workloads? What network does it flow over? What use case user am I accessing it from? And what device do I actually present that on? Very complex from that standpoint. So, when you think about the challenges of this hybrid network footprint, I'm going to go large grain in this particular area, and part of it is the use case that I'll highlight. But oftentimes, basically, there's this core distance problem. When we were dealing only with private networks or public networks, in many cases, the distance problem was known. You knew when you were building out a data center, you built out a data center maybe in a region such as EMEA or Asia Pac, replicated the data centers, maybe had a hot type of configuration or disaster recovery type of configuration. And from that standpoint, you knew where you actually had to get to in relation to solving that distance problem. At the same time frame, when you move to things like SaaS or compute storage workload, when you're moving those particular workloads around, you don't know exactly where those data centers might be. The second piece basically is that the data problem, moving these new classes of applications, oftentimes not just web-centric, but collaboration-centric, are moving new protocols actually into the web. CIFS and MAPI, usually flowing very seamlessly over the private networks, now have to traverse over the public networks and off of SaaS infrastructures, and it brings new performance environments basically into play. And the last piece is the access problem. This idea of the backhauling. It's not uncommon for many of the large enterprises to have thousands of branches actually out there, but only have a handful of internet gateways by which they're actually accessing those particular access to the internet from those 1,000 branches. And it creates a tremendous latency problem backhauling over the private network and then over the public network as well. So let me look at one use case here, and then I'll talk a little bit about a solution set that can actually be done here, and I think is being explored by many other vendors in the industry, one of them being Akamai and some of its partners. But one of the use cases here is that much of the data center applications are moving themselves actually into the public cloud environment. They move in the form basically of SaaS-based applications, in this case basic Office 365 or Salesforce, or in the form of compute workloads that you're putting on a GoGrid, an OpSource, a Terramark, or an Amazon, or a Rackspace. In the traditional sense, basically, we used to provide application acceleration technologies over the open internet. And in the private-based environment, optimized WAN environments from Cisco WAS or Riverbed existed to link these two environments actually together. The use case that's essentially coming up and popping itself up that is more of this hybrid use case is when folks actually have to now traverse across the private network environment and then over the public network environment to actually access these types of applications. When this happens, this backhaul effect actually happens. You not only have to traverse over the private network, but then you have to leave the environment of that optimized environment, typically actually provided by your WAN optimization vendor, and then over the open internet. And in the open internet, where Akamai usually basically has had an effect in relation to optimization, it no longer can actually take that handoff, or has in the past not been able to take that handoff and deliver a level of scale and quality of service actually over this open internet. So, the idea of virtualization and the idea of hosting virtualization itself has helped in tremendous amount in relation to scale up. In the WAN optimization environment, in this hybrid network architecture, it's giving you the ability to scale out. Where in the case basic of solution sets that you'll find in this particular area, you have approximately 150,000 steelhead devices, Riverbed steelhead devices across corporate networks today. And Akamai has approximately, let's say, 100,000 network servers actually in the internet actually today. And in the hybrid class environment, what you're trying to do is create a fabric across both environments so that you can deliver a quality of service and performance. And this is where virtual machine technology basically is helping in the scale-out component, opposed to in the data center was very much a scale-up type of component. Where if Akamai on its 100,000 servers can host a process like a Riverbed steelhead process within its network, and something like a Riverbed steelhead device can host a Akamai process within its environment. From an Akamai perspective, it allows Akamai to actually get into the data center of a private network environment and into the branch where the steelhead device actually is and extend its overlay network across that public network environment. From a Riverbed or any one of the WAN optimization players in the market today, What it allows them to do is to take a virtual steelhead device, optimization device, and extend that and put that into a footprint across any one of the Akamai edge regions. And in this case, you have points of presence over 1,000 basically within the public internet environment. And the design goal there is that on the public network environment is to be no less than 20 milliseconds away from where the end users are accessing any one of their applications and content and information. And of course, basically, when you're talking on the private network, you typically have WAN optimization devices that are right at the edge of the network in the branches or directly in the locations. So in essence, you have an environment basically where the optimized environment that's over the open internet exists in the private network, and the private network actually exists in the public network, creating essentially this optimized fabric across both environments. You know, what then happens is you can apply these techniques. They're fairly well known, so I won't spend a lot of time on this, and I think there's some breakout sessions later today that kind of gets to this point. But if you can actually design an architecture along these lines, what it allows you to do is actually apply a unique set of network optimization techniques that typically has been associated to either the public environment or the private environment, but not in the hybrid environment. One of the main elements that's actually part of this WAN optimization piece is that the fastest way, basically, that you can move data from point A to point B, some say basically is don't move it at all. And so you have caching and deduping capabilities that allow us to actually do that. In this case, essentially what you can do in the dedupe capabilities is maintain these libraries of these data sets that you actually see flow over the network. And essentially what ends up happening is if you can actually be in both ends, and now when you're talking about the hybrid environment, you're talking one in the public environment, one in the private environment, can you actually provide a data library that says, I've seen this before, only send this thing that's basically the delta of it. The second area basically is to optimize the connections. Can you get end-to-end transport and connectivity between the private network and the public network, and essentially virtually eliminating latency and virtually eliminating essentially the inefficiencies of TCP. And then the last thing is, again, over that hybrid-based environment, can you then have a level of visibility that essentially says, hey, give quality of service or priority to a class of traffic as it flows over the public and private network environment. So when you take a look at this fabric itself, the unique properties in relation to it isn't the internet alone or isn't the private network alone. The unique properties in this particular environment is the ability to actually extend this footprint actually to this mixed and hybrid environment. And the unique property that it allows for those of you who are adopting cloud computing and cloud stacks is that with this fabric in place, it allows you to actually move your compute and workloads dynamically within the public network and the private network environment, but ensure a quality of service over the network environment that's both optimized and gives you a quality of service and control that you didn't have over the two fabrics basically independently. So, you know, just a couple of things in terms of stats. So a very simple scenario here is if you take something like Office 365, many people, and a lot of this is being pushed by Microsoft itself because this is the licensing model that they're pushing forward into the future, is that if you establish an account on Office 365, and in this particular use case, you're simply a user in Cambridge actually establishing an account, it'll establish you in a data center in Chicago. But without any optimization that's actually in place, simple BGP routing will typically route you to Chicago through Dallas if you're accessing it from Cambridge. And so one of the things that's, again, part of this is that typically is something that you wouldn't have to deal with in a private network environment. But by providing essentially optimization over this hybrid footprint, what you can do is actually get essentially a factor of 2x in relation to the latency reduced. Now, on a web-based application, that's not so great. But you know what? When you're actually talking about email, and you're talking about the chattiness of CIFS and mapping, and you're talking about documents transferring, it can be quite significant. So take, for example, when you move these environments, and these are the impacts of actually getting to this virtual stack in relation to computing. When you move from on-premise and you're moving something like a 10 megabit file and sending that, like my presentation today, and moving that to actually 5 users, it's going over the LAN, which is the 10 megabit pipe basically, or 100, then of course the impacts aren't that great. You move that actually to the cloud, and the impact in relation to a milliseconds going from 25 milliseconds to 85 milliseconds can be quite significant. Just some statistics in relation to it. You can take a look at the time dimension on the bottom. You can tell basically this graph was actually created by an engineer because time dimension is on the bottom, megabits on the top, a little bit hard to read. But if you just simply take a look at this, what this is telling you is that if you have an optimized method of delivery that's over this particular fabric, what you can realize is essentially something that's going from 124 seconds essentially down to essentially 5 seconds, and something that essentially goes from 15 seconds to 49 seconds, and probably most importantly, is the response time is essentially the amount of bits that are transferred. If you look at the impact in relation to utilizing this technology, and again, the unique property here is the use of this technology across the hybrid network footprint. Again, something that was very difficult to implement in the past. And most importantly, again, as you move these compute workloads. So a key element of what I'm talking about here is the byproduct of what you're talking about in a hybrid cloud network is while you're utilizing and deciding what virtual stack or what cloud computing stack to actually go with, you can't ignore the impact that it will have on the network. And when you're evaluating the network impact, you have to evaluate the optimization basically of the traffic and application workloads across both the public and private network environment and how you make that seamlessly across both. So let me just talk a little bit about global access and mobile. And again, what happens when you add the network fabric component to it? And again, what I'm talking about here is when you add essentially these characteristics onto the network that's traversing primarily over the public internet, what happens in this particular area? You know, if you think about Marriott.com in 1996, I'm using Marriott.com, and I know we're in the Hyatt today, but if you're using Marriott.com as just simply the example, I'm using it as an example in terms of content. Whether it's an enterprise application or, in this case, basically a consumer-based application, the trends and the characteristics and attributes of the applications are going in the same direction. Marriott.com, 1996, very simple. You go to 2000, it's a little bit more complex. It looks a lot like the first generations of Yahoo. 2005, a little bit better, a little bit more dynamic. And then if you take a look at Marriott today, even more so is how dynamic the site really can be when you look at delivering this basically over the internet. And in many cases, most of the enterprise applications that I'm seeing today also actually have a great deal of these type properties, and they're compound applications within that environment. You know, if you look at that from a performance challenge, and again, the network impact basically that happens when you're delivering these applications, the content is heavier, JavaScript inefficiencies in delivering that rich content basically is heavier. The chattiness of the protocols that are actually implemented are impacting download time. Third-party content. We have some folks basically and you can think about third-party content as a compound app actually calling another application, or in some cases in the commerce world, beacons or other third-party content adding to the user experience, or things like reviews that are actually impacting in the commerce environment. Third-party content. In some cases, we've had up to 50% of the content on the site actually coming from someplace else. And what that leads to basically is user expectations essentially in terms of download time are quite high, even though essentially when they have this richness, they'd like it to be at a very, very fast and nimble instant site or application. And the cost to actually get there is also very dramatic. And then you factor in the devices. As we mentioned before, in terms of mobile, the sprawl basically in relation to what devices is that the expectations in terms of the user experience remains the same regardless of what the device actually is. So they get heavier content, they have more complex JavaScript and chattier protocols, they have content coming from all over the place, and they want it form-fitted actually as it relates basically to the mobile device. And when you think of it from that standpoint in relation to that, what ends up happening is you can apply, again, in this particular area, apply network optimizations as you've seen basically in what we just talked about, protocol optimizations, again, that live in the cloud, front-end app optimizations, again, that live in the cloud. Many of you may hear a lot about this about WCO, or Web Content Optimization. Gartner calls it front-end optimization. It's the ability to actually take content itself, manipulate that, and optimize it basically for device or for performance in relation to the way basically that website was actually designed. In this particular case, what it does is it deals with very, very ill-developed websites and as it relates to a protocol aspect of it, and allows you to apply technology to it to allow that website to perform much better. And then the last piece is basically in terms of third-party optimization is how do you then optimize content coming from a compound app or a third party. And the last piece is mobile optimization itself, and maybe even transcoding that says if it's this device, then present these particular images or this site in this particular fashion. So in this particular case, if you think about it, when you're thinking about all these elements that are actually coming through, that bottom layer is part of the DNA that you have to evaluate as you think about providing these types of applications over this next generation environment. The last area, when you really think about the performance, is certain things that you may or may not be able to control. From a network perspective, those who have worked in the wireless network space environment understand this, that the IP networks, the things that we have in terms of the wireline networks today, have lots of optimization associated to it. You can buy them from Akamai. You can buy them basically from the carriers. You can buy them from other folks basically who can optimize these experiences as it relates to it. The challenge as it relates to basically the mobile or the cell networks is that the optimization only goes so far into the cell networks. And oftentimes, the usability of content is challenged, but just the raw performance of it basically on a mobile device or intelligent device. Utilizing this as an example, again, this is another example where virtual machine technology and VMs in itself has given companies like Akamai and others the ability to scale out instead of scale up. What if we were able to take, again, a VM version basically of the Akamai server, the same ones that we're using with partners like Riverbed and IBM, but deploy them deeper into the cell networks, deploy them inside of the cell networks and as close to the cell towers as much as possible. What that means is that all the things in the fabrics that we've talked about, protocol optimization, network optimizations, front-end optimizations, all of that intelligence that we typically get at the edge of the network actually today, you can extend not just basically to the IP networks, but into the cell networks if these server entities actually can make it deeper into the network. And so the environments that are created, if you think about this in relation to mobile, are extended through partnerships. Because usually, just like Riverbed, what you're going to find is that you're going to find a dominant player basically in the private network environment, and you're going to find, in many cases, a dominant player in the public internet. And that's very much the case basically that you find in the cellular networks as well. Again, you have Akamai, who's been a dominant player basically on the open internet, allows us to actually provide a variety of services as it relates to that. But in the cell networks, you're going to find large players, of course, like people like Ericsson, and where Ericsson itself already has footprint directly actually in the cell networks itself. By Akamai partnering with these other players in relation to it, it allows itself to put these value-added services directly into the cloud. In this case, the cloud is an extension basically of what we know as the internet, and it's the cell networks. And by doing it from this standpoint, what it allows us to do is extend the optimizations that we talked about in the network, not just over the open internet, not just in the private networks, but then also extend this environment directly into the cell networks, because we know the explosion of devices is quite pervasive. About 500 million communication devices are sold every quarter. About 25% of those basically are smartphones. And so there's no doubt between that, the iPad, and a number of tablets, that the use case for how people will actually use these applications in the future will extend actually into these new devices. And when thinking about that, that optimization at the network level has to extend all the way across that particular fabric. Now, the last area that I'll just touch upon in the network DNA component is really security. And it's less about transport, and it's more about essentially protection and defense. And what comes to mind here really is one of the questions sometimes basically that's directly related is, what is the biggest network that folks typically think of when they think about on the internet? Do I have any hands there in relation to the biggest network? Sometimes people think of Akamai, other Google, even Apple basically with their iTunes network. Very few people basically when they think about this, does it come up? Because oftentimes Akamai will talk about its footprint on the open internet, its ability to be at the edges. You'll hear carriers talk about their footprint in terms of a global network worldwide. Everybody knows the pervasiveness basically of Google as it relates essentially to wherever you're at. It can be a wireless app, it could be a Google search engine, whatever it actually means, but the Google footprint is quite pervasive. Very few people think of the biggest network in the form basically of things like bot networks. But something like Conficker is a network essentially of 10 million bots, north of 10 million bots, able to actually generate spam of approximately 10 billion spam hits basically across its particular network. So when you think about it from that standpoint, a lot of what this biggest network in the security portion is because the exposure in the cloud is quite great when you think about the people who are marshaling this energy, malicious energy, have access in some cases to the largest networks in the world. And so when you think of it from that standpoint, a lot of the cloud concerns, especially when they branch into this hybrid environment, is definitely around security being the number one piece. And a lot of it actually being because of these bot networks and the agility of user groups basically to harness the power of them and be able to maliciously attack a number of these environments, whether it's Walmart and Capital One or essentially some of the WikiLeaks pieces that we've seen a while back. This is definitely an exposure, and then basically the cloud and the network component plays a role here from a protection and defense perspective. So let me talk a little bit about that element of it. First of all, there's this element of just simply what's the attack volume per year. And when you think about it, it's getting to such a point that whether you're utilizing a private network or you're utilizing essentially one of the cloud providers' cloud stacks, the thing that you have to be aware of is simply just how large basically is the capacity necessary to thwart any one of these attacks when they have essentially a bot network of the size of Conficker that they can marshal that support against a particular site or application. The other element in relation to it is just some of the things that we see in terms of the agility and smarts of the networks themselves. We've seen over 100% of traffic of denial of service attacks actually grow over the course of the Akamai network, just in 2010 and 2011 alone. And keep in mind that Akamai sees about 30% of all internet traffic. The sizes of the attacks are even getting greater. But probably the thing that's probably most important is that the attacks themselves are originating from different geographies and are highly coordinated. So you're talking about intelligent bot networks where the instrumentation of how they attack, when they attack, the method of their attack is quite coordinated. And so using that use case in relation to it, like if we just took a look at last year during the holiday season, and I bring this up because we're simply on the verge of the next holiday shopping season, is there were several, I think there was over 20 coordinated attacks that we saw through the shopping season. I'm just profiling one here. But in this particular case, to piece things actually together, in this particular case, this was not associated to wikis or anything of that sort. This is simply an independent attack. What we saw across that is across customer 1, customer 2, customer 3. Essentially, on the timestamp was a very coordinated attack where what you saw in terms of these graphs is traffic basically hitting a particular site or application increase at essentially dynamically the very same time frame, and the profile of the attack actually being very much the same as well. If you look at the statistics on customer 1, customer 2, customer 3, again, what you're going to see basically is a very coordinated attack. And in this particular case, we grouped all these together because the attack pattern was exactly the same or very similar in nature. So when you consider basically going to the cloud and taking advantage of the agility, the cost savings, the performance and scale of what's actually going in the cloud, when you're moving into these hybrid network environments, you're going to have to actually deal with the fact that this open exposure to your applications oftentimes will actually happen, whether you're renting that application from a cloud provider or you yourself basically are hosting that yourselves. A way to think of this basically is that when you actually have a cloud data center and a malicious attack actually imposes it, if you're using acceleration networks, one of the good things is it makes things fast. If you're using acceleration networks and an attack actually comes to your site and it looks like a valid user, what does the acceleration network do? Of course, it speeds up that attack, right, at a massive velocity. So one of the things that's really important is to add a level of security intelligence and layer over this particular fabric. And a lot of this can be thought of basically in relation to what goes into the cloud. If you can put essentially a network defense into the cloud, if you can put a layer 7 application defense actually into the cloud, when the hacking or this type of attack actually tends to happen, probably the most important thing is that where it's thwarted is in its place of origin. So if the bot network actually is originating in Korea, in China, or in the United States, or some part of the country, it essentially is going to be stopped by the edge perimeter network essentially in that particular geography. And so very much basically like real war, you don't want to actually do battle on your playing field. You want to do battle basically exactly where the fight basically begins and avoid it actually coming to your data center, which would be analogous to your homeland soil. In this particular case, by putting things like web application firewall technology, intelligent rule sets, you get both a network component that allows you to create this buffer as well as an intelligence at the layer 7 environment to avoid things like the anonymous types of hackers that actually happen across Walmart and some of the other sites. And we saw this, and we see it every day where even if they have these networks and the networks themselves basically are smart enough to take down a particular region of a cloud perimeter defense, the intelligence should be such that it can fail over to the next particular region, and the users themselves see very, very little delta in relation to their user experience because it's dynamically actually moving around the resources available basically to the end users. And this is, of course, the value of the cloud in relation to its perimeter. I bring this up simply because earlier this week, because of the anonymous attacks, we had a large media customer of ours who had a number of perimeter defense elements actually up. Their particular sites were attacked. I think there was 5 of them that were attacked. And due to having essentially a number of these web application firewall rule sets and our ability essentially to thwart these threats at the edge of the network, much of their infrastructure actually stayed up and running while, of course, folks basically who were not protected in this particular environment either had data stolen or essentially their sites became unavailable. So, think of it this way. When you're thinking about the cloud and networks, I talked about optimization, and I talked about essentially extending that optimization over the hybrid environment for both the public and private network environment. Also think about cloud optimization in relation to an extension to your security and defense perimeter. So in essence, essentially, if you can think of that you have your standard data center environment with multiple origin security systems in place, you're going to have your hardware WAF, you're going to have your firewall, and you're going to have the stack of environments basically to provide that denial of service on-premise. Essentially, what you're thinking about in terms of cloud security is the ability basically to create the perimeter defense once it extends actually out into the cloud. And so it's an addition to that, and oftentimes can work in a collaborative nature with the hardware that you have on premise. Integrate and correlate in relation to the systems, as well as the rules, and provide real-time and visibility reporting from the edge all the way back to your data center. And this itself will provide both just essentially a defense mechanism that is essentially hardened and working with your data center, but now at the perimeter of the network. So I've talked about essentially 3 components. One of the hybrid network, the mobile, and then essentially the security and defense center. It's in this spirit basically that you essentially have 3 use cases where you're thinking about the way you're doing your application workloads. One is you have your data center and you're picking a set of technologies and server infrastructure that allows you to virtualize that cloud stack. And in this case, basically, you own the data center and you actually own the app. The other use case is essentially you have an application that you're choosing to put on compute or storage infrastructure out into the public internet. You don't own the infrastructure it's running on, but you own the application it's actually running on. And then the third one is a SaaS environment. You're renting the application and you're renting the infrastructure that it actually runs on. I guess the point that I'm making across these models is these are all valid use cases that most enterprises that I'm talking to today are adopting one of 3, not just one, but essentially all 3. They have applications in their data center. They are moving stuff to compute workloads and storage workloads, either in OpSource, in Rackspace, in Amazon, in Terramark, and they're utilizing things like Office 365, Salesforce.com, Oracle On Demand, and so they have each one of these use cases. If you do, you're going to run into some of the core challenges that I had mentioned across those three particular elements, the hybrid network, the mobile, and the security environment, which essentially brings us to this idea of the next generation network. The next generation network, this is just essentially Akamai, apple pie, and motherhood stuff, but the next generation network is really all about the fact that the growth in both the public and private network environment that we see is actually going to happen at an unbelievable pace. So you'll see growth in both of those environments. So what you'll need is you'll need this control plane that will extend across both environments. You know, if you think about your tiers, in the past you've had essentially this database tier in lots of environments where you can think about how can I optimize the edge of the database, and that's typically still in the data center. And then we've built application servers and a lot of application acceleration technologies, again, within the data center. And they say, well, how do I optimize the edge of the application? And then again, you've seen a lot in relation to the web and the data center tier. You know, what I'm talking about here essentially in terms of the fourth generation network, I mean the next generation network, is this kind of fourth tier. Essentially, how can you actually add as an extension to your data center essentially this control that you typically had at your origin infrastructure, but now extend that actually out into the open internet to the edge of the network where your users actually are. This is exactly what the cloud providers on the network side are all about. Akamai is in that business. If you think about it, basically there's other folks directly in this business, but if you're evaluating cloud computing from a network perspective, whether it be from Akamai or others, this is the environment that you're looking to. How do you get the extension basically from your origin infrastructure, and that origin could be a cloud provider or your own data center, but provide you the same level of control basically extending over the open internet. And what that essentially will provide you is that if you take a look at public and private clouds, over this particular fabric you'll have the public and private cloud infrastructure, and what you'll be looking for is the deployment of a control plane. Because you'll have your corporate data centers, you'll have your infrastructure as service applications where you'll move your compute and storage workloads there. You'll likely be using something like Salesforce.com, Office 365, Oracle On Demand, or a variety of applications basically that help productivity or help increase revenue or decrease costs within your enterprise. And then you'll access it from everywhere from the open internet to the branch offices. If you have presence basically, you'll want fabric that route optimizes across these two environments. You'll want transport protocol optimization that goes end-to-end across these two environments. You'll want application optimization at the application level protocol or at the content level with web content optimization or front-end optimization at that environment. And then one of the emerging spaces that you'll see more and more is that you'll want security and policy management to be done right at the edge of the network. And the reason why this will be an emerging space is because if you can make security and policy management decisions at the edge of the hybrid network, you can make decisions on routing and optimization on whether or not that class of traffic or that user or that class of application gets routed over the private network or the public network environment. This has never been a dynamic that we've seen before because it's always been essentially rooted in one place or the other. But this will be one of the things that will continue to evolve. And with that said, I think one of the things that we'll be looking for is that Akamai, we believe, has an edge in this particular area. There's certainly other players actually in the market space, actually providing optimization that will make these cloud computing network environments actually go over a hybrid network environment. The cloud environment is here to stay, and if you actually do it right, you won't get one of those clouds, essentially, that's a bad cloud, essentially, but you'll have a successful launch and hopefully experience all of the benefits that you typically would get from cloud computing, which includes the agility, the cost reduction, the performance and scale, and more importantly, the competitive advantage that you're looking to drive towards your business. Thanks for joining us earlier this morning. I want to thank the conference for hosting us in relation and giving Akamai a chance to actually address a little bit about the cloud DNA, but from the network perspective. Thanks again.
Thank you so much, Willie. We're now